Hi everyone, today we're going to talk about systems of equations and solving them with the substitution method. So just to give you an overview, what are we doing? We are solving one of the equations for one of its variables. Then we're going to substitute whatever we got for that variable. So x equals, let's say 2x or 2y plus 5. We substitute that in to step 2 into the revised equation from step 1 and we solve it. So let's go through some examples. Here's our first one. What we see here is that x is equal to 2 minus 2y. So what we're going to do is we are going to take this 2 minus 2y for the x, and instead of x in our equation, we're going to substitute that in. So my new equation is going to be 2 times the quantity, 2 minus 2y, plus 3y equals negative 1. And by doing this, I'm going to have one variable I can solve for, figure out what value that's equal to, and plug it in to find the other. So first up, I'm going to distribute. So I'm going to get 4 minus 4y plus 3y equals negative 1. And I'm going to combine my like terms. So I'm going to have 4 minus 1y equals negative 1. So let's see here. 4 minus y equals negative 1. And I'm going to subtract 4 from each side. And I'm going to end up with negative y equals a negative 5. And if I divided those both by negative 1, I would get y is equal to a positive 5. So that's my y value. So remember, this is the intersection. If we remember from graphing, this is the intersection of our two lines. So that's the y coordinate of our point where they intersect. Now I'm going to plug that in for the x here. So I'm going to have x is equal to 2 minus 2 times y, but we got 5 for that y. So I'm taking this equation right here, and I'm just plugging my y value in so I can figure out what x is. So x is equal to 2 minus 2 times 5 is 10. So what's x? X is equal to a negative 8. So I know the solution is at negative 8 for the x coordinate, 5 for the y coordinate. And if I plug those in, I should see that they work here. So if I plug them in and check them with my equation, then I see that my solution is correct. So when you're doing these, you should always be able to see if you are correct before you're even done with the problem. I'll plug it into the first equation over here. So this is my checking of it. First equation, negative 8 in for the x. 2 minus 2 times 5. So I get negative 8 is equal to 2 minus 10, which is negative 8. So that one worked out. My second one, 2 times the negative 8 plus 3 times 5 should be equal to negative 1. Well, 2 times negative 8 is negative 16. 3 times 5 is 15. And yep, that's equal to negative 1. So that works out. Okay, we're going to look at this example here, and we will notice it's a little bit different than the last one because I don't have a y equals or an x equals. But this will be pretty easy to get y equals with this second equation. So to do that, I'm going to add 2 to both sides, 2x, to both sides. And when I do that, I get y equals 2x plus 4. Okay, well now if I use this equation in the top equation, it's going to look pretty similar to what we've done in the past. So what I'm going to do is I'm going to substitute this 2x plus 4 in for the y of the top equation. And working over to the side, I'm going to have 3x plus 2 times that quantity, 2x plus 4, equals 1. Now I'm going to solve for x. So I'm going to end up with 3x. I'm going to distribute that 2x. So I'm going to have plus 4x plus 8 equals 1. And I end up with a 7x plus 8 equals 1. And I can subtract 8 from both sides. I get 7x equals a negative 7, or x is equal to negative 1 after I divide both sides by 7. Okay, now I can go ahead and solve for y, and I'm going to plug that negative 1 back in to my y equals equation to make it kind of easy for myself in for the x. So when I do that, I'm going to plug it in for this x right here. So I'm going to have y equals 2 times negative 1 plus 4. So y equals negative 2 plus 4, and y equals positive 2. So what does that mean mathematically? That these two lines are intersecting at the order pair -1, +2. And that is my solution. Got one last example we're going to work through together here. And once again, I'm going to try to get one of the variables by itself. It looks like this y from the top equation would be easiest to get alone. So if I do that, 2x plus y, I'm just rewriting it over here, equals 5. I'm going to subtract 2x from both sides. And I get y is equal to -2x plus 5. Now I can go ahead and plug that value in for y into the second equation right here. So I'll have 4x plus 2 times -2x plus 5 equals 6. So I'm distributing that positive 2, so I get 4x minus 4x plus 5 equals 6. Well, what happens over here? My 4x's drop out and I get 5 equals 6. So is that possible? No, it is not possible. Oops, I'm sorry, I realize I have a mistake here. This should be a 10, and this should be a 10. So again, 10 equals 6. Not possible, that's never going to be true, so that tells us we have a no solution. So what does that mean graphically? It means we have two lines that are never going to cross each other, and they are parallel lines, so therefore it is going to be a no solution. So hopefully you have a few examples you can work through. Here's your homework. We're just going to be looking at the book part right here. So 3 through 14 and then 28 and 33. Don't forget there are also videos on the book website that you can look at too. I hope you have a great day.